Hi, welcome to watch the Ditron digital readout and linear scale installation video. As you all may know that the digital readout and the linear scale system always gives the convenience, enjoyment and accuracy to the operators when they are operating the manual machines. It is so good to use, but it is such a pain for them to install them onto the machines. And today, we will show you how to proceed this installation process. We will take our breakport as a demonstration. And this video will involve 5 parts. Okay, let's go ahead to see what I am talking about. The first part will be the unit introduction. Okay, let's open the box and to see what we will use today. Okay, that's what we have taken out from the box. This is a 3-axis digital readout, and this is the manual of this digital readout. Here is the screw for installation, the bracket. This is the power cable, and this will be the tool holder used together with this bracket. This is a linear scale package carton. Let's open to see what we have got. Okay, that's what we have taken out from the linear package. This is a 900mm scale, and it's covered here. The screws, washer and shim for the installation. And this is a 400mm scale, and it's covered at the pad strip for the installation. This is a 450mm scale, cover, pad strip, and the screws, shim, washer for the installation. Here also we got a manual. On it there is a brief introduction for the installation. You can also use this when you are during the installation. And these are the brackets for the installation. Let's move to see this linear scale. And we have taken out the cover. This will be the pad strip for the installation. For some machines, when the base level is not so good, we need to use this to build another good base level for the installation. As you can see, there are installation holes. These 2 holes are for the pad strip installation onto the machines. After installed wear of this pad strip, we can install the linear scale onto this pad strip. There are 2 installation holes for the linear scales. Here we move to have an overlook of this digital readout. As you can see, there is a PU cover for this digital readout. During your operation, you can leave it on for the protection against the coolant water and the oil. But for today's, we can have a better look of the demonstration. I will take it out for show you. As you know, this is a full function and a smart digital readout, and we have insert 3 models inside: mini machine model, EDM model, laser models. We can, for some customers, they want to buy a 3-axis digital readout, but just install 2-axis. Later, he will consider to buy another axis. So we have the functions to close 1 axis. Just use 2 axes on this 3-axis digital readout. I will show you some basic parameter settings. First, we turn on the digital readout. To press inch button to enter the model choose. This will show you the models we have now. 3L means 3 axis for lasers. Use the direction button to switch the model. 3M means 3 axis for mini machines. 3E means 3 axis for EDM model. Also, to choose how many axes we will use, press the button 1. Here we show the 3V, that means 3 axis we will use. To use the direction button to switch. 2V, that means 2 axis just will be used. I will show you. To press the dot button to save the parameter settings. Now, just the 2 axis we displayed. This axis closed. I will show you again. As you can see that now we just use the 2 axes, But now we need to switch back to 3 axis again. We turn off the digital readout, turn on again, and press MMH button when the digital readout is during the self-checking process. Please remember that this setting need to press the MMH button during the digital readout is during the self-checking process. Now we press button 1 to 3 ways, that means 2 axes we will use. Here we also can set to 1 axis, but now we need to switch back to 3 axes again. 3 way. That is means we will use 3 axes. Also we can choose, because for some Western customers, for the inch model, sometimes some customers want to use 5 digits during the inch model, but some customers just want to use 4 digits during the inch model. So we can also choose how many digits we can use to press the dot 2. That inch 5, that means 5 digits were used under the inch model. Here we can choose 4. That means during the inch model we will just use 4 digits. And to save these parameter settings, we just press the dot button. We switch the inch. This is metric model. We switch to inch model. Now you see they just 4 digits. Okay. Now we know how many axes we will use, and the model switch by settings by switching MMH button during the digital readout self-checking process. We move to another process to set the parameter settings by press the dot button during the digital readout is during self-checking process. We will show you. Now pressing the dot button during the self-checking, and here we can see that it's a linear tap. This DRO can connected used together with the linear scale, also a rotary encoder. Here this axis displays linear, that means now we can use it together with the linear scale by pressing X0, that shows rotary. So at this moment, this axis can connected with the rotary encoder to display the angle. Here we back again to choose the linear scale. And also we switch to see what we can set next. That's the resolution settings. Here we have some options in the software by pressing the X0. That means 10 macro, 1.1 macro, 0.2 macro. We go back to 5 macro. Same to the wrist axis, press this button, Y0 or 0. 0.5, 1 macro, 2 macro, 2.5 macro, and 5 macro. Same. This is also same setting. 10 macro, 0.1. We go back to 5 macro. And next, to see what each we can set. This is a direction setting. To set which direction is negative or positive by pressing X0. Also same here. That's a composition setting for this. This is a linear composition. We press X0 to go on linear tap settings, compositions. We go back to linear. That's what we can set. To save this parameter settings, we press dot buttons here. The second problem will be that it is not accurate for this whole system. The first reason you need to check is whether the machines, after long time running, the vibration of the machines will cause the screw loosen. At this moment, you need to check the scales fixed. If not fixed, to tighten with the machines. And the second reason will be the resolution setting. The resolution set on the digital readout need to be same as the linear scales, such as if the linear scale is 5 macro resolution, you need to set the resolution of the digital readout as 5 macro also. Previously, we have introduced the parameter system settings, and now we will show you the two common functions which is used frequently. That are the diameter and the radius change, and also the linear composition. First will be the diameter and the radius change. The step 1 will turn on the digital radar and press inch button immediately, and then choose the model to L. L means lasers, and press the dot button to save the parameter settings. Now this digital radar is for the lasers. At this moment, press X button and then the half button. As you can see, there is a triangle displayed there. This means the diameters. This is the diameters. And how to set back to the radius, press X button and then half button. That will be the radius. For the linear composition functions, we also need to turn on the digital radar. And then press the dot button and use the direction button to choose. This will be the compositions. Linear indicates the linear composition. We can also to change by press X0. That will be unlinear. Unlinear indicates the unlinear compositions. Now we need to switch back to the linear composition. And now we press the dot button to save the above parameter settings. How to get the compensated value? We have a formula here. LD. LD means the displayed value on the digital radar. LA means the actual value. And there, LD minus LA and divide LA, then multiply by 1000. That will be the compensated value. We will take an example. For example, the displayed value is 601, and the actual value is 600 millimeter. We use this formula we can get here. This is the compensated value. After we get the compensated value, we need to input this value into the digital radar. How to input? By press X and then inch button. At this moment, you can input the values here. By press Enter. Now we have finished this process. And for the Y and the Z axis, we can use the same settings to do the linear compositions.